Alright, let's look at this problem. Find the values of x and y that make the red lines parallel and the blue lines parallel. Okay. Here are the red lines, they are horizontal, and the blue lines are slanting. So again, we look at all the properties that form when lines are parallel. So here, let's consider the blue lines first. These two blue lines, if they are parallel, or they were parallel, then means the red line will be transversal. And if you notice, these two angles are on the same side of the red line. So, and they are interior, inside the blue line. So same side interior. So same side interior are supplementary. So 1 minus 40 plus x plus 40, which is that angle, plus that angle, is equal to 180, because same side interior angles are supplementary. They add up to be 180. We collect like terms. So x plus x is 2x. And then, well, negative 40 plus positive 40 is 0. So we actually have 2x equals 180. Therefore, x, we divide both sides by 60 by 2. So x is equal to 90 degrees. X is 90 degrees. That means if we replace x with 90 here, 90 minus 40 would give us 50. So this angle right here is 50, angle 50. Okay. Then how about y? How do we find y? Okay, then let's consider the red lines. If the red lines were parallel, then this blue line will be transversal. And again, we notice that this angle and this and y are on the same side, on the right side of this blue line. So we use same side again. If we look at that, it's on page. So we can say angle x minus 40 plus angle y is equal to 180, because same side interior angles are supplementary. So we already found what x is. So x is 90. So we can actually substitute that. Minus 40 plus y equals 180. So if we simplify, collecting like times 90 minus 40 would be 90 minus 40 would be 50. We already found. So minus y, or plus y, sorry. So we subtract 50 from both sides. We subtract 50 from both sides. Then y is going to equal 130. So if we make y to be 130 and make x to be 90, then the blue lines and the red lines will be parallel. Alright, how about this one? Here is the two red lines, this and this. If these two red lines are parallel, then the blue line will be transversal. And what do we know? Well, we know this angle to be 105, and this angle and angle 3x, they are on the opposite side of the blue line. So they are alternate, and they are inside the red line. So they are interior, alternate interior. Alternate interior angles are congruent. So 3x would equal 105. And therefore, x would equal, divide both sides by 3. Okay. So that's 105. We plug into the calculator. 105 divided by 3. Okay, that's 35. So x is equal to 35. All right, how about y? What do we have that connects y? Okay, we go to, there's 2y here. 2y. We know this angle. Do we know this angle? Well, if we consider the blue lines, this blue line, if this blue line is parallel to this blue line, what happens about this angle we don't know, and this angle x here. We notice that if they are parallel, because it goes from the black line to the blue line, from the black line to the blue line, so that means they are going to be corresponding. So here would be x also. And we already found angle x, which is 35. So we know this angle is actually 35. We know it's angle 35 degrees. Okay. Or we can just write x equals. Okay, so with that, we can find these three angles. They are supplementary. They add up to be 180. So we know angle 35 plus 105 plus 2y is equal to 180. Okay, that's angle addition postulate of angle on a straight line. Again, we already know that angle x is supplementary corresponding to that. That's how we found that. So if we add this up, so 105 plus 35 is equal to 140. So we have 140 plus 2y equals 180. So if we subtract 140 from both sides, so 2y is going to equal, again, 180 minus 140 is going to be 40. So y is going to be 40 divided by 2, so which is 20. Okay, so y is 20 and x is 35 to make those parallel.